Today we're going to solve quadratic equations by the square root method. So make sure you go ahead and get your date, your page number, and your learning target. Before we get started, we're going to talk about what a quadratic is. Remember, quadratics are the U-shaped graphs, which means the exponent on it is going to be an x squared. So what we're actually doing when we're solving a quadratic is we're looking for the solutions. There's a couple of different things you can call solutions. So if I'm looking at a graph of a quadratic, and I'm looking at this parabola, okay, what I'm actually looking for when I talk about solving a quadratic are these 2 points right here, which if you remember, those are called your x-intercepts. So whenever you solve, you're looking for x-intercepts. Those can be called x-intercepts. Those can be called solutions. When you're told to find the solutions, that's what they're asking you to find, is the x-intercepts, where it crosses the x-axis. It can be called the zeros of the function. And it can be called the roots of the function. So anytime you're asked to find the x-intercepts, where it crosses the x-axis, the solutions, the zeros, or the roots, this is what you're being asked to do, is to solve it. So there's a couple different methods. The first one I'm going to teach you is the square root method. So before we start on the square root method, what you need to remember is algebra's golden rule. What you do to one side of the equation, you have to do to the other. So let's look at example 1. I've got a function like this. And if you remember, if I had this equal to 0, it would be the function x squared minus 36. And if you remember, that means that this has been shifted down 36 units. If I looked at the graph, it's been shifted down 36, and it goes up here like this. So you're trying to figure out, if after it's been shifted down 36, where does it cross? And what you should have done yesterday or today is talk about the how to solve it based on a graph. So since you've solved it based on a graph, this is kind of ugly. I wouldn't want to graph something like this. I wouldn't want to have to draw an x and y axis that went all the way down to negative 36 and then count up 1, right 1, up 3, right 1, up 5, right 1. So that's why we have another method. Whenever I have this method, all I'm doing is I'm trying to get x by itself. So you're basically solving the equation. So we're already part of the way there. We've already got 36 on the other side. But now I'm trying to get x by itself. So that means I have to undo this square. In order to undo something squared, you would take the square root of both sides. Now here's the difference. You're going to have to take plus or minus the square root, and I'll show you why in just a second. Well, when I take the square root of x squared, that's just x. Remember, I did that just to undo that. Okay? And when I take the square root of 36, I should get 6. So my answer is positive 6 and negative 6. So when I talk about where it crosses the x-axis and my solutions, I'm talking about the points negative 6, 0 and positive 6, 0. So again, let's think back to what that looked like. It was shifted down 36. And it went up here. It should cross at 2 different places. So it makes sense that I would have a positive and a negative. And it wasn't shifted left or right any, so they should be the same way, points away from the axis. Another way to think about that would be what you're doing when you're solving for x is trying to figure out what has to multiply to give you 36 by itself. Well, 6 times 6 is 36, but so is negative 6 times negative 6, because a negative times a negative is a positive, which is why you have to do plus or minus when you're actually taking the square root. So let's try another example. I'm trying to solve for x, which means I need to get x by itself. So there's 2 things being done to x here. One is being added to x, and then the whole thing is being squared. So I've got to decide what I should undo first. Well, before I can get inside this parentheses and start subtracting 1, I've got to take this square off because the whole thing's being squared. So in order to undo that, I need to take plus or minus the square root of both sides. That over here will undo this square, and the only thing left is x plus 1. And over here, I get plus or minus the square root of 49, which is 7. And I don't need these parentheses anymore because I took off what was being, like, what the parentheses were needed for. Parentheses were needed for that square. So I can take those off. So I've got x plus 1 equals positive and negative 7. So what that means is you get two different answers. X plus 1 is equal to positive 7, and then x plus 1 is equal to negative 7. And it should make sense that I get two different answers because we've already talked about that. So subtract 1, and one of my solutions is 6. So the ordered pair 6, 0 is a solution. And the other one is negative 8. So the ordered pair negative 8, 0 is a solution. Or a root. Okay, well let's talk about this one. So the only thing being done to x is square, so in order to undo that again, I need to take plus or minus the square root. When I do that on this side, I'm just left with x. On this side, I get plus or minus. Well, the square root of 32 doesn't come out even, but we want to know exactly where it crosses. So that's not good enough. We're going to have to actually break down square root of 32 and simplify our radical like we've done before, because you want exact answers here. You want to know exactly where it crosses. So I can break this down into 16 times 2. 16 breaks down into 4 times 4. I can break down the 4s, but again, remember, I don't want to because there are a couple they're going to leave anyway. So x is equal to positive 4 square root of 2 and negative 4 square root of 2. So my ordered pairs are kind of ugly this time, but that's where it crosses exactly. Okay? So again, this is why we have multiple methods, because the graph method wouldn't work here. You wouldn't be able to see that it crossed at 4 square root of 2 exactly.